minutes. Alrighty, everybody. I just got the okay to start our planetarium show, so we're gonna be shifting gears real quick. We're gonna be heading into the unknown. Ooh, hee hee hee. And once again, everybody, welcome to the Morrison Planetarium. I just want to introduce myself real quick. My name is Christian. I'm gonna be your planetarium presenter for this showing. And just to let you know, I'm not a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward into the dome before you. That's where the whole show's going to be. I just want to let you know that I'm here. I'm going to be your planetarium presenter and space pilot in this planetarium. And just to let you know, folks, the show that we're going to be doing here is one of my personal favorites. I love this show. What we're going to be doing right now is called Tour of the Universe. And essentially, what this means is that we're going to start off pretty close to planet Earth, and we're going to zoom all the way out to the very edge of the known universe using our really cool space software that we use here in the planetarium. So, hopefully, by the end of the show, you won't have an existential crisis of where we are in the universe, but just to let you know, we are very small in the grand scheme of things. And before we get started, I got to go over quick house rules just so that we're all on the same page. We can have a great experience inside the planetarium. First off, there's no food or drinks allowed inside. If you manage to bring any snacks or beverages, make sure those are tucked away till the very end of the show. We want to make sure this theater stays nice and clean for all of our folks coming in the future. This also does include no feetsies on the seatsies because, again, we want to make sure the seats stay nice and clean for all of our guests. Also, folks, if you happen to have any 21st century gadgets like cell phones or smartwatches, tablets, anything that produces bright white light, now is the perfect time to turn them off, deactivate them, put them away for the next 30 minutes. These devices, again, produce really bright white light, and in a very dark environment like this planetarium, can be distracting for the folks sitting behind you. So we want to be courteous to all of our guests here in the planetarium. Also, folks, the biggest of them all, please wear your mask at all times while you're inside the planetarium dome above your nose. There's about 50 of us in here. We're going to be here for 30 minutes. So again, please wear your mask throughout the entirety of this presentation. Thank you so much, y'all. And also, folks, if you need to leave the planetarium for any reason, you're more than welcome to do so. All we ask is that you exit through the top of the planetarium. So if you need to leave, make sure you go up the stairs, not down them. These stairs are very steep. They're made of concrete. You can easily trip and fall in the dark. Trust me, I know I have bruises. You don't want these bruises. So always make your way up the stairs, not down. And lastly, folks, this show can be quite immersive. We have our 75-foot dome above us. If at any moment during the show it becomes too overwhelming, you become motion sensitive, there's a really quick and easy way to ground yourself. All you got to do is close your eyes, take a few big deep breaths. Your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling through space, at least not more than the usual. Hee hee hee. But otherwise, we are ready to go. Are y'all ready for a fun planetarium show? Yeah, alrighty, everybody, sit back, relax, and let's get started with Tour of the Universe. Whoa. Alrighty, everybody. So again, as I mentioned, we're starting off pretty close to Earth. You can see the Earth just below this object that we're looking at. In fact, right now, it looks like we're hovering just above Italy. So we can see it on the night side. We can see all the city lights down below illuminating. We can also see all the way to different parts of Europe as well. But I want to focus on what we're looking at right now. Right now, it kind of looks like we're looking at a satellite, but what we're looking at is something much cooler, in my opinion. Uh, this is what we call the International Space Station. We also like to call it the ISS for short. But essentially, what the International Space Station is, this is a research facility that conducts all sorts of different types of experiments out here in low gravitational environment, so kind of out here in space. And this is a collaboration between many nations across planet Earth to pretty much figure out what happens to things in space. So some of the experiments that they've conducted out here is like, how do plants grow out here with no gravity or very low gravity? Does water behave the same way when you try to drink a cup of water? And of course, what happens when you spark a fire or ignite a fire? Does it behave the same way? So these are some of the different types of experiments they conduct up here on the International Space Station. And just to let you know, this thing is relatively new. It first began in 1998, thanks to Russia. They sent the first module out here into low orbit, and it's actually right in the middle of the International Space Station. So this International Space Station is made up of 13 different modules. So over time, they kept adding new modules to it, so it keeps getting bigger every year. So the first one's like right here in the middle. But what's also really amazing about the International Space Station is that it's not too far away from planet Earth. It looks really enormous on our screen right now, and really far away from Earth, but it's only about 250 miles above the surface of the Earth. 250 miles, that's not too far. That's like driving from San Francisco to Santa Barbara, a nice little road trip with the family to get away with for the weekend. And just to let you know, folks, this International Space Station is going incredibly fast. It's going a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And the International Space Station can house about 6 to 8 astronauts at a given time. And it's supposed to be discontinued in 2028. But if they keep managing and keeping good maintenance to it, it can continue a little bit longer beyond that. And just to let you know, folks, this is as far as we put humans into space nowadays, because traveling into space gets quite costly quite rapidly. First, you need to get yourself a rocket ship to get you off the planet, or build yourself a rocket ship. And then you're going to need a lot of rocket fuel to get that rocket ship and that rocket fuel off the planet. And not only that, you also have to bring all the crew and all the food, water, and all the air you're going to be breathing in space. So the bill starts to get quite costly quite rapidly. But we're going to leave the International Space Station behind, and now we're going to slowly see it disappear down below compared to planet Earth and in the night lights. And as we start to lose sight of the International Space Station, I will bring up its trajectory so we can still keep an eye on where it is compared to planet Earth. It's nicely represented by this orange line that we're seeing. And just to let you know, folks, the space software that we're using here is something that you can download at home. This is something called OpenSpace. If you go to Google and type in openspaceproject.com, you'll find this software. You can download it at home. But just a heads up, this thing uses a lot of information and needs a lot of processing power. So if you have a really amazingly well-processed computer or desktop, highly recommend downloading this. Just go to openspaceproject.com. But now that we've left planet Earth, we're going to be heading over to our nearest natural neighbor to us in space, the moon. So let's shift gears and head on over to our nearest natural neighbor to us in space. And as we make our way to the moon, it looks like we are in new moon, so we can't really see it from our side. We can actually see the little silhouette of the moon as we approach it. But since I'm in a planetarium, or we're all in a planetarium, I can do special things in here. So I want to turn off the nighttime on the moon so we can get a better look at it. And there it is. Now, just to let you know, folks, we humans have been to the moon before, but that was quite a while ago. This was between 1969 and 1972, thanks to NASA's 6 Apollo missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They even got to conduct science experiments, and they even got to play golf up here as well. But again, that was the last time was in 1972, so that was a little more than 50 years ago or so. But don't worry, NASA has a new space mission in the works that should be launching in about a few years or so. Hopefully everything goes according to plan. But this new space mission is called Artemis. So Artemis is going to be sending the first woman to the moon. But not only that, they're also going to be sending the first person of color to the moon. And not only that, they're also going to be setting up the first lunar base on the moon. Essentially, the goal of NASA is to send humans to Mars. But before we send humans deep into our solar system, about a 2-year voyage away from us, we need to figure out how exactly humans are going to live in a celestial body out here in space, something that's not like Earth. So instead of sending them all the way to Mars, really far away, the moon is the perfect stepping stone. And it's not too far away from the Earth, about a 3-day voyage on a rocket ship. So in the coming years, look out for any news about Artemis setting up the first lunar base. And they will also have their own international space station of the sorts. It's going to be called Lunar Gateway, which is going to be orbiting around the moon during this whole mission. So if anything goes wrong while they're on the moon, they can launch it back and head to the space station orbiting around the moon. So very cool stuff. But folks, here on Earth, when we look up at the moon, it almost feels like you can reach the moon with your arms, especially when you reach out and touch it, and especially when the moon is low to the horizon. But the moon's incredibly far away from us here on Earth. It's about 240,000 miles away. Whew, that's 250,000 miles. Now, for the adults in the room, some of you may own a car with that many miles on it. And if you can even imagine driving to the moon and you were going 80 miles per hour, it would take you 4 months nonstop. Although I cannot recommend it, the roads out here are poorly maintained. He. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities. So astronomers instead use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But also a really cool way to think about it is if you had a friend on the moon and you were here on Earth, you shined a laser to your friend on the moon, it would take that laser to reach them 1.5 seconds to cross that distance. So incredibly fast. But for now, folks, we're going to leave the moon behind. So everybody say bye-bye, moon. We'll see you later. And now, folks, we're going to be heading into a much greater realm of our solar system because now we're going to watch the moon and the Earth and their orbits as they slowly recede. And on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer models like OpenSpace showing us the most accurate images and information available to us. And as we start to lose sight of the moon, I want to bring up the orbits of our planet so we can figure out where everything is out here because space is very vast. Ooh, it sure does take a while to get out here in space. But now, folks, it looks like the nearest star to us comes into view, the sun. And the sun's about 93 million miles away from the Earth. That is a very far distance. So 93 million miles away, in terms of light speed, that's only about 8.5 minutes at the speed of light. So remember, Earth is the third rock from the sun. So we have 1, 2, 3. It takes 93 million miles for that sunlight to reach us here on Earth. or 8.5 minutes. But what's also really cool is that if the sun wants to turn off all of a sudden, we wouldn't know about it here on Earth for 8.5 minutes because, again, it takes that long for that sunlight to reach us. Now, this is a really amazing concept to keep in mind because this also works for really further distance objects. For example, let's say we're looking at a star that's 2 light years away. Well, we're looking at that star as it looked like 2 years ago in the past because it took that long for that light to reach us here on Earth to observe it. So when you're looking out at very far objects in space, it's kind of like looking back in time of a sort. But since we have a nice bird's eye view of our solar system, let's name the planets really quickly since we're here. So of course we have the sun right in the middle. That's a star. And then the closest planet to the sun, we have Mercury. And then after that, we have Venus, Earth, and Mars. These are the rocky terrestrial planets. These are places we can actually land a spacecraft on. And then beyond Mars, we have something called the main asteroid belt. And if we were to highlight all the asteroids in the asteroid belt, it would look something like this. Now, a lot of people tend to think that the asteroid belt is filled with asteroids, and you're not wrong there, but Hollywood and cartoons tend to make it look like that if you're trying to fly your spacecraft through the asteroid belt, you would be dodging and weaving. But actually, the asteroid belt is so spread out, and there's so much space in between all these asteroids, you can easily fly your spacecraft through this asteroid belt. There's about a 1 in a billion chance of your spacecraft getting hit by an asteroid, so very low chance. But beyond the asteroid belt, we have the really big planets. We have the gas giants. Of course, we have the biggest one, Jupiter, and after that, we have Saturn, the Jovians. And then beyond those, we have the icy giants. We have Uranus, the funny one, and Neptune. And of course, I can always bring Pluto's orbit into the mix. Here's the orbit of Pluto. Now, just to let you know, folks, Pluto is no longer considered a planet as the year 2006, and a lot of people tend to get some confusion about it. Why did Pluto get kicked out of the Planet Club? Well, it turns out in the year 2006, we got really good about learning about the outer part of our solar system, specifically the orbit beyond Neptune in a region called the Kuiper Belt. And you're probably wondering to yourself, what's the Kuiper Belt? I've never heard of that before. Well, the Kuiper Belt, folks, is going to be all this stuff. So the Kuiper Belt is essentially a second asteroid belt. That's why we have the main asteroid belt closer to Mars and Jupiter. And then this is the Kuiper Belt. So this is mostly made up of icy asteroids and icy comets as well. But not only that, they also have a lot of dwarf planets out here. Essentially, in 2006, astronomers found a whole heap of objects, the Kuiper Belt, more than 4,000 objects out here. Some of them were way bigger than Pluto, so we couldn't call all this stuff planets. There was just way too many of them. So all the astronomers came together across planet Earth, had a great big meeting. They had to figure out what exactly you need to be considered a planet. And in order to be considered a planet, one of the criteria is that you need to be so big and so massive that you push all the other objects out of your orbital path. Unfortunately for Pluto, it doesn't meet that qualification, and it actually dances around its own moon. So this is one of the reasons why Pluto got kicked or demoted to a dwarf planet instead of an actual planet. But don't worry, Pluto's not the only dwarf planet out here. We've got quite a few. We've got Makemake, Haumea, just to name a few. And of course, we also have Ceres in the main asteroid belt closer to us. But I want to put away the Kuiper Belt, and I want to be bringing up some of the spacecrafts that we sent out in the 1970s to explore our solar system. So here are all the trajectories of all the different spacecrafts that we sent out since the 1970s. Here we have Pioneer 10, Pioneer 11, Voyager 1, Voyager 2, and of course, the latest of them all, New Horizons. And we can actually see that New Horizons did a quick flyby of Pluto. We can see this interaction right over the very top. This happened in 2015, and essentially New Horizons did a quick flyby, got some amazing high-definition images of Pluto, and then continued on its way. Before then, our photos of Pluto were pretty much pixelated dots, and we couldn't get a whole lot of information out of those images. But folks, we're going to leave our planetary system behind now, because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us over 4 years at the speed of light to reach the next star system to us, the Alpha Centauri system. And not only that, also our star becomes one of many of all the other nearby stars close to us as well. We just look like another star out here in space. And if my calculations are correct, I do believe the Alpha Centauri system is going to be The one slightly below us, this star system, so that's us, Alpha Centauri, just below, 4 years at the speed of light to reach the next star system to us. So quite a long journey. But folks, we're going to stop and consider whether humanity has made its presence known beyond the stars, because now we're going to be heading inside something called the radiosphere. So again, we are now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. Now, this first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All these things are emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. Now, humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. Now, since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year. So is anybody out there listening? And folks, I'm going to be now bringing up seeing some of these markers. These markers represent some of the many thousands of stars astronomers have discovered over the last 22 years, which has at least one or more planet orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far to date, we found more than 4,000 exoplanets in the general region closest to us. Now, not only that, we have whole space-based telescopes devoted to just looking for as many exoplanets as possible. In fact, if you look at the very top left of the screen, we can see a whole heap of exoplanets. That's just one direction that we pointed our space-based telescopes, and they found a whole heap of exoplanets in that direction. So it's a matter of time as we continue scanning more of the night sky. That 4,000 exoplanet marker planet number is going to be increasing as the years continue. But figuring out if any of these exoplanets are Earth-like with conditions suitable for life, well, that's a whole different story. Our technology is not yet able to answer that question, but new generations of astronomical instruments are devoted for that search. But the important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there that's able to listen in and answer back, the communication delays between hellos could be decades in time. Now, just to give you an example, let's say we live in, let's say this solar system right over here. We find an alien civilization on the other side of our radiosphere. We shoot them a text message, hi. They listen in, answer back, hi. That is a 180-year conversation in the making. Whew. And I could barely wait for a text message from my friend. But of course, folks, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And I want to put away these exoplanet markers, but I want to leave our radiosphere up on the screen. As huge as humanity's electromagnetic footprint is, it is nothing compared to the structure of the Milky Way galaxy that we live in. So keep your eye on that radiosphere. Let's see if you can still see it as we look down in our Milky Way galaxy. Alrighty, folks, we are looking down at our Milky Way galaxy, and can anybody see their house from here? Just kidding. But of course, we are looking down on the Milky Way, and just to let you know, folks, our galaxy is incredibly large. If you wanted to transverse or cross our galaxy from one side to the other, it's going to take you 130,000 years at the speed of light. Now, that is a very long road trip. But not only that, our Milky Way is so huge, we estimate that there's at least 300 billion stars in this galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave the Milky Way galaxy, I do want to stress the shape of it. When we look at the Milky Way galaxy from a sideways perspective, you're going to notice that we live in a flat spiral disk of a galaxy. Now, this is going to come important a little bit later on the show, so just keep this in mind. We live in a flat spiral disk. When astronomers and scientists want to learn about the universe, it's much more convenient for them to point their telescopes and equipment galactically north and galactically south, instead of looking through the plane of the Milky Way, which has planets, nebula, stars, gas, debris, which obscures their view of the universe beyond. So just keep that in mind. We live in a flat spiral disk. But folks, the Milky Way is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, we're now about to see a view where each point of light represents not a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And just to let you know, we live in a local group of galaxies, which contains about 30 galaxies, large and small. It also includes the largest spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door, and we're heading right for it. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue zooming out, folks, you're going to start to notice that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, and they like to avoid each other and create large regions or voids. You can see quite a few galaxy clusters right over here. They're usually labeled in orange. And then again, you can see empty regions where very few galaxies hang out in. So just keep that in mind. Galaxies like to hang out in large groups or avoid each other. And just to let you know, folks, the photo that we're looking at now represents the 30,000 closest galaxies to us in space over 300 million light years across. We've got to give thanks to an amazing astronomer by the name of Dr. Brent Tolley, who worked over decades of time that gave us this amazing galactic map that we're able to fly through in this planetarium today. So big shout out to Dr. Brent Tolley for working very, very hard to give us this amazing map. But now we have automated systems that are mapping even the most distant galaxies. So now, folks, we are about to see the large-scale structure of the universe. And remember, folks, every single point of light that you're seeing is not a star. It's an individual galaxy. Ooh. And also, just to let you know, the universe we live in right now is not shaped like a butterfly or a bow tie. Remember when I just mentioned that we live in a flat spiral disk of the Milky Way? Well, if we were to line up our Milky Way galaxy, it would line up perfectly like this, where these dark regions are. So again, astronomers point their telescopes galactically north and south instead of looking through the gas and debris of our Milky Way galaxy. But astronomers still want to make sure that there was galaxies in through the Milky Way plane. So we have this nice purple survey of galaxies right here. You can also notice that these galaxies don't go as far as compared to the other ones because of all that gas and debris that obscures the view of the Milky Way, or our view, yep. But eventually, as our technology gets better and advances, we'll be able to look through the plane of the Milky Way and we'll be able to map galaxies in every direction that we can. But folks, it looks like we're running drastically out of time, so we must continue on. And as we do so, we are now about to approach these objects known as quasars. And the quasars are these orange objects at the very edge of the large-scale structure. You can see them on the left side of the screen or on the bottom side of the screen. Oop, looks like we're flying through some right now. But essentially, with the quasars, we're viewing these very young, very distant galaxies, again known as quasars, and they're short for quasi-stellar radio sources. And these blazing objects are all billions of light years away, so now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So now we're going to look much further back before a time before quasars, before planets, stars, and even galaxies began to form. Folks, we are about to approach the very edge of the known universe. And here we are. So folks, we are now looking at what we call the cosmic microwave background image. We also like to use a hyphenated, abbreviated version, the CMB image. Now, all evidence indicates that the universe we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And this is a picture of a very baby version of the universe. It's only 380,000 years after the Big Bang occurred, so not too long after the start, where space and time began. And what we're looking at is not a typical photo either. Instead, we're looking at a temperature density image where the light echoes of the Big Bang are color-coded, where the lighter areas correspond to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely, extremely tiny. They vary no more than 1 part per 100,000. But eventually, they gave rise to the large scale structure of the universe, that clumping and clustering of galaxies everywhere that we saw moments ago. Figuring out how this happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, it looks like we've traveled as far back as the law of physics can physically allow us, so we only have one direction left to go, back home. And before we make our return trip back to planet Earth, I do have to warn everybody to prepare yourself because this could possibly be the worst free falling dream ever. Hee hee hee. But let's find a nice entry point through all these quasars and galaxies, and let's make our return trip back to planet Earth. And folks, just to let you know, we are across an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts extending the reaches of our eyes. We're preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we are making our way back into our Milky Way galaxy. We're heading straight to that radiosphere. And of course, we are making our way downtown, walking fast, faces passing, we're homebound. And it looks like we are approaching our star system, passing those spacecrafts we sent out in the 1970s to explore our solar system, making our way past the main belt, and of course we are approaching the third rock from the sun, our little place in the vastness of space, the only place humans have ever called home. But as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with me today. I hope you did enjoy it. And with that, that's all I have for you today. And I hope you all get home safe. Thank you, everyone.